zeros of a polynomial function. First, let's go over the remainder theorem. If the polynomial p of x is divided by x minus r, then the remainder is p of r. So let's go ahead and see how this remainder theorem works. Suppose p of x is the polynomial 2x cubed minus 3x squared plus 5x minus 7. Let's find p of 5 by substitution. So remember, to find the function value p of 5, we're just going to plug 5 in for x. So everywhere we see an x here, we're going to plug in the number 5. So that's going to give us 2 times 5 to the third power minus 3 times 5 to the second power plus 5 times 5 minus 7. And if we do the math here, we have 2 times 5 to the third is 125 minus 3 times 5 squared is 25 plus 5 times 5 minus 7. Now let's do the multiplication. 2 times 125 is 250 minus 3 times 25 is 75 plus 5 times 5 is 25 minus 7. And now if we do the math here, we have 250 minus 75, which is 175, plus 25 is 200, minus 7 is 193. So we know that p of 5 is 193, which basically means when you plug in 5 for x, you get 193 for y, right? Because p of x is just the same thing as y. So now the remainder theorem says that the function value p of r is the same as the remainder when you divide by x minus r. So if we took the polynomial 2x cubed minus 3x squared plus 5x minus 7, and we divided it by x minus 5, right? Because we're dividing by x minus r, and in this case, r is 5, right? R is this number here. Then we can do this division using synthetic division. So remember, what we do is we put the opposite of this number here in the box, which means we put 5 in the box. And then we represent our polynomial 2x cubed, negative 3x squared, positive 5x, and negative 7. And let's go through the synthetic division process, and keep in mind that whatever you get here, this is going to be your remainder. So if this is true, this should be 193, right? Okay, so let's go through it. 2 comes down. We're going to multiply 5 times 2, which gives us 10. And then we have negative 3 plus 10, which is positive 7. And now 5 times 7 is 35. And 5 plus 35 is 40. And then we have 5 times 40, which is 200. And negative 7 plus 200 is 193. So why is this theorem important? I mean, it's interesting, isn't it, that the function value is the same as the remainder when you divide by x minus the value that you're plugging into the function? But really what you should notice is that this process here is much easier to do than this, right? The computations here are much simpler. So with polynomials, if I want to find a function value, yes, I can plug the number into the function, but I can also use synthetic division to plug the number into the function. So it gives us some options. In our next example, a small company can manufacture between 50 and 300 pre-recorded DVDs each day with a daily cost of C of x is equal to this polynomial. Find the daily cost to manufacture 100 DVDs a day and the cost to manufacture 200 DVDs in a day. So all they're asking us to do is to find the cost of manufacturing 100 and then to find the cost of manufacturing 200. So they're just asking us to plug 100 and 200 into this function. Now you could do that. You could just plug it in, but we're going to use the remainder theorem to do this. So let's start with 100. If I want to find the cost of producing 100, I need to put down our coefficients here. So we have 0.0002 x cubed, and then negative 0.03 x squared, and then 4x, and finally 800. And the way this works, we're going to bring down this first number. And of course, what we're looking for is the remainder that we get in the box here. All right, so let's go ahead and do this. So 100 times 0.0002 turns out to be 0.02. And now negative 0.03 plus 0.02 is negative 0.01. Then we have 100 times negative 0.01, and that's actually just negative 1. 4 plus negative 1 is 3. 100 times 3 is 300, and 800 plus 300 is 1,100. So the cost to produce 100 DVDs is 1,100. Now, what about 200 DVDs? Well, we're just going to plug 200 into the function, which means we just need to change this number here to 200. Now, of course, that's going to change all of the values that we get here. So let's go ahead and clear the space here. So let's multiply. 200 times 0.0002 is going to be 0.04. Negative 0.03 plus 0.04 is positive 0.01. 200 times 0.01 is 2. 4 plus 2 is 6. And 200 times 6 is 1,200. And if we add that together, we get 2,000. So the cost to produce 200 DVDs is $2,000. So now we have perhaps the most important theorem. This is the factor theorem for polynomials. It says the binomial x minus r is a factor of the polynomial p of x if and only if p of r is equal to 0. So what this means is that if p of r is equal to 0, this implies that x minus r is a factor of p of x. And it also says that if x minus r is a factor of p of x, this implies that p of r is equal to 0. So that's what is meant when they say if and only if. It means that if this is true, then we know this is true. And conversely, if this is true, we know that this is true. So for example, in this problem it says, find a polynomial p of x such that p of 2 equals 0, p of 1 equals 0, and p of negative 2 equals 0. So let's start with p of 2 equals 0. If p of 2 is equal to 0, this means that x minus 2 is a factor of p of x. The next one says p of 1 is equal to 0. Well, if p of 1 is equal to 0, this implies that x minus 1 is a factor of p of x. And finally, p of negative 2 equals 0. this means that x minus negative 2, which is the same as x plus 2, is a factor of p of x. So what do we know about p of x? We know that p of x has to be made up of these factors. So p of x has to be x minus 2 multiplied by x minus 1 multiplied by x plus 2. And we can multiply this out. So let's go ahead and multiply these two first. So if you do the math on that, you should get x squared plus x minus 2. And if we continue to multiply here, right, we're going to multiply all of these and all of these. This is going to give us x to the third power plus x to the second power minus 2x. And then down below here, we have negative 2 times x squared. I'll write that here. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. And if we combine like terms, we have x cubed minus x squared minus 4x plus 4. And so we know that this polynomial must have these factors, right? Because we multiplied them out. Furthermore, if you plug in the number 2, 1, or negative 2 into this polynomial, you will get 0. And you can verify that on your own if you like. So knowing when a polynomial equals 0 tells you about the polynomial. It tells you what the factor is of that polynomial. So now a question. Is x minus 4 a factor of p of x? Well, if it is, so if it is a factor, then that would mean that p of 4 would have to equal 0. So when they ask, is x minus 4 a factor of p of x, what we're really asking is p of 4 equal to 0? So let's answer that question. Let's use synthetic division. We'll put 4 in the box. We have 4x cubed, negative 16x squared, negative 9x, and positive 36. Let's do the math. 4 times 4 is 16. Negative 16 plus 16 is 0. 4 times 0 is 0. Negative 9 plus 0 is negative 9. And 4 times negative 9 is negative 36. And 36 minus 36 is 0. So we now know p of 4 is equal to 0. Therefore, x minus 4 is a factor of this polynomial. So the answer here is yes. So next we have a definition. If p of x is a polynomial and p of r is equal to 0, then we say that r is a 0 of p of x. So a number is called a 0 of a polynomial if when you plug in that number, you get 0 for the polynomial. All right. So let's see how we can use that to solve the following problem. We want to solve the equation x cubed minus 5x plus 2 is equal to 0. So think about if I have some polynomial p of x equal to this polynomial here. When I set that equal to 0, I'm trying to figure out when is p of x equal to 0, right? So for what values of x? So what they're asking us to do is find the zeros of p of x. Now, they're telling us that x equals 2 is one solution to this equation. So they're basically telling us that x equals 2 is a 0 of p of x. So they've given us one of the zeros. We want to find the others. So what we can do is we can use synthetic division. We'll start by putting the number that we know is a 0 in the box. Now, p of x is 1x cubed, 0x squared, negative 5x, and positive 2. Let's verify that we get 0 for our remainder. 2 times 1 is 2. Then we add. 2 times 2 is 4. Then we add. 2 times negative 1 is negative 2. And yes, we have 0 there. Now, what this tells us is that p of x is the polynomial x minus 2 multiplied by what's left over here. Now, keep in mind that this is 1x squared plus 2x minus 1. Okay? So knowing that x equals 2 is a 0 of the polynomial allows us to factor p of x into x minus 2 multiplied by what remains. So now if I want to find the other solutions, I need to set this equal to 0, right? Because remember, I'm trying to figure out when is this polynomial equal to 0. Well, clearly x equals 2 is one answer, right? But we already knew that. So now I need to set this polynomial equal to 0, and I need to solve. Now for this, it doesn't factor, so I'm going to use the quadratic formula, and I will do this silently. So make sure you can follow along here, right? Make sure you know the quadratic formula. This gives us negative 2 plus or minus the square root of 4, and then plus 4 divided by 2. This is negative 2 plus or minus the square root of 8 divided by 2. Square root of 8 we can simplify into 2 radical 2. And then dividing each one of these by 2 gives us negative 1 plus or minus radical 2. So there's two solutions here. There's negative 1 plus radical 2, and there's negative 1 minus radical 2. And these are the other two solutions to the original equation. So in the next problem, they want us to find all zeros of the polynomial p of x that you see here if you know 3 is one of the zeros. Now, I would like to point out that this is exactly what we did in the previous problem, okay? So if we go back and take a look at that previous problem, what they did here is they worded the problem differently, right? They said, solve this equation completely if x equals 2 is one of the solutions. But since the equation was basically a polynomial equals 0, they were basically asking us to find the zeros of the polynomial, even though that's not what they said to do. In this problem, they're wording it in this way. Find the zeros of p of x if you know that 3 is one of the zeros. So we'll start with the fact that we know 3 is one of the zeros. We're going to use synthetic division to divide the polynomial by x minus 3, right? Which is what we're doing when we put positive 3 in the box. So let's bring this down. 3 times 6 is 18. And if we add, we get negative 7. 3 times negative 7 is negative 21. And then if we add, we get negative 5. And 3 times negative 5 is negative 15. And if you add those, you get 0. And we expected this, right? Because they told us it was a 0. So now we know that p of x is equal to x minus 3, right? That's what we get from this. And we're going to multiply that by the factor that we get from there. And that factor is 6x squared minus 7x minus 5. So now to solve for the other zeros, we're going to do the same thing that we did in the last problem. So again, we know x equals 3 is one of the zeros, right? That comes from here. But now I'm going to set this equal to 0. So 6x squared minus 7x minus 5 equals 0. You could try solving this by factoring, right? So if you want, we can use a magic X here. We have 6 times negative 5 is negative 30, and a negative 7. And what are the factors of negative 30 that we can add to get negative 7? I believe that would be negative 10 and positive 3. And so the way this is going to factor is going to start looking like this. But then remember, you have to divide each of these by 6 because you have a 6 here. And so this becomes x minus 5/3, x plus 1/2. And if we put this in the correct format, the factorization here is this: 3x minus 5 multiplied by 2x plus 1. So now if I set each one of those factors equal to 0, here I'm going to get x equals 5/3, and here we will get x equals negative 1/2. So these are the other two zeros, okay? So it says find all zeros of p of x if you know 3 is one of the zeros. So all of the zeros of p of x would be these 3 numbers here. Now I want you to notice that when you have a third degree polynomial, do you notice that it has 3 zeros, right? That's not a coincidence, okay? So the degree of the polynomial gives us information about the number of zeros. In our final example, the cost to a company to produce X units of a product is given by the cost function that you see here. The revenue the company expects to realize from the sale of X units of the product is given by the function that you see here. If P of X represents the profit realized on the sale of X units, compute and interpret the profit of selling 20 units. Okay, so first of all, we need to know that profit is equal to revenue minus cost. So profit is the money that you bring in minus the cost that it costs you to produce the things that you're selling. So the profit function P of X is going to be R of X minus C of X. And R of X is negative 1.1 x squared plus 41.5 times x minus the quantity C of X, which is 0.02 x cubed minus 0.5 x squared plus 10x plus 150. So we need to distribute the negative here, like so. So this is going to be negative 0.02 x cubed, positive 0.5 x squared, and negative 10x, and negative 150. And then don't forget to bring these first two terms down here. And now we just need to combine like terms. So our P of X is going to be, let's put it in order. We have negative 0.02 x cubed. And then next we have the x squared terms. And if we add those together, we get negative 0.6 x squared. And then we have positive 41.5x minus 10x. This is positive 31.5 times x, and then minus 150. So this is our profit function, and now we just want to find P of 20. And of course, there's two ways you can do this. You could just plug 20 in for x, and that would be fine. But I'm going to go ahead and use synthetic division to do this because I find it to be a little bit easier. So we have negative 0.02, negative 0.6, 31.5, and negative 150. And let's go ahead and do these computations now. So 20 times negative 0.02 is negative 0.4. Negative 0.6 plus negative 0.4 is negative 1. 20 times negative 1 is negative 20. And then if we add here, we get 11.5. And finally, 20 times 11.5 is 230. And negative 150 plus 230 is 80. So P of 20 is equal to 80. And what does that mean? Well, it means that if you sell 20 units, this is going to give us $80 of profit. And that concludes this video lesson.